Hello everyone. This video covers the lecture notes for week number 12. The two main topics we're going to cover in the video are vertical asymptotes and horizontal asymptotes. There is also a special type called slant asymptotes, but this is related to horizontal asymptotes. Now, before we go into detail on the topics or getting too deep into the topics, let me explain very quickly what a vertical asymptote is, because technically you already know this, you just don't know that you know it. If you ever seen a graph that has a dotted line like this, and then you notice that the graph could do this or this, but it doesn't cross that line, this line is not part of the domain, that's why it cannot be crossed, and this will be a vertical asymptote. So technically the vertical asymptotes are pretty much depend 100% on the domain. Then a horizontal asymptote will be something that looks like this. Let's say you have a graph that looks like this, and it settles to y, let's say, equals to 2. So therefore here the horizontal asymptote will be y equals to 2, and the vertical will be x equals to, let's say this is 4. Okay. So vertical asymptotes is going to be x equals to, horizontal y equals to. So that's how you can tell the difference between the two right away. Also, the horizontal asymptotes are very related to what we did before, what we call end behavior. The big difference is that we did end behavior before only for polynomials, and now we're going to do it for a rational function. By the way, a rational function, okay, so note, a rational function is just a function which we're going to call Rx for lack of a better name, where you have a polynomial divided by another polynomial. So that's what a rational function is. Okay? Right, let's look to the next example. And this is going to explain clearly what a horizontal asymptote is and a vertical asymptote is, hopefully. So here it is. Here they give you a table, and you want to check what happens as x gets bigger and bigger, which means that's the end behavior. So here you have 1 over 1 will give you 1. 1 over 10 is 0.1. This is 0.01, 0.001. So you can clearly see that as x goes to infinity, this will go to 0. Okay? The same thing will happen here. This will be minus 1, minus 0.1, minus 0.01, minus 0.001, and therefore clearly this will be minus 0. Okay? So as x gets bigger and bigger, therefore the value for y is going to 0. So therefore this means that the horizontal asymptote is going to be y equals to 0. So the graph will look like this. When x is 1, this will be 1. Obviously we're not going to go to infinity. When x is minus 1, this is minus 1, the graph will look like this. Okay? So you can see that the end behavior is going to be what I just told you right now. As x goes to infinity, this goes to 0. And as x goes to minus infinity, this goes to 0 also. This is going to be very important once you take calculus. Now, let's look to the vertical asymptote, sorry. Notice how this line, I didn't cross it when we did the line, and here is the reason why. As you're getting closer and closer to now to 0 from either the right side or from the left side, that's what this plus or minus means. Again, 1 over 1 is 1. 1 over 0.1 is actually 10. 1 over 0.01 is actually 100. You should check this is the case. This is 1000, so you can see that this goes to infinity, which should be obvious from here. Then This will give you minus 1, minus 100, sorry, minus 10, minus 100, minus 1000. So therefore this will be minus infinity, which again is obvious from the graph. So that means that this line, which you can cross, this will be the horizontal, sorry, the vertical asymptote. So the vertical asymptote will be x equals to 0, okay? So now let's just rewrite what we just found. It says the function f of x has a horizontal asymptote of what, y equals to 0, and a vertical asymptote of x equals to 0. Now I just use this notation, but just to be clear, this means x approaches 0 from the left. This means x approaches 0 from the right. This is actually a notation from calculus. This means x goes to infinity, and this negative infinity, and this goes to infinity. Okay, so that's just the notation, which is kind of new. Now, before we go to the next page, something that is very, very important to notice here, there are two things you should be aware and make a note of this. Notice that if I were to ask you what is the domain of this function, which I have asked you about the domain like 10 times so far, remember for the domain there are only two things you cannot do. You cannot take square roots of negative numbers, and you cannot divide by 0. So clearly here the domain for this graph, the domain is that x cannot be 0. And notice that the vertical asymptote is x equals to 0. So that's no accident. This is a huge connection that you need to be aware of. Okay? And second, notice that when you divide by a big number, the answer is always going to be 0, which you can see from here. As x gets bigger and bigger, then you're dividing by a bigger number, you will get 0. So just think about this. If you have this function, let's say you have a pizza, you divide by one person, you will get the whole pizza. You divide by two people, you will get one half of the pizza. By 4, you will get 1/4, and so forth. You divide it by a billion people, you will get nothing, pretty much. So that's why this is equals to 0. All right, so now I literally just told you this part right now, but let's just tell you this one more time. It says the line x equals to a, let's say, is this, x equals to a. It's a vertical asymptote of the function y equals to f of x if what? 1, x equals to a is not part of the domain. Okay. And 2, the graph of f of x doesn't cross the line x equals to a. Okay, so that's what it means to be a vertical asymptote. All right, so now it says draw a graph of the function g of x with a vertical asymptote of x equals to 1. So x equals to 1 is here. The graph has to satisfy these conditions. It says that as x approaches 1 from the right side, this has to go to infinity. And when x approaches 1 from the left side, it also has to go to infinity. So when you're getting closer and closer to 1 from the right side or the left side, the graph has to go to infinity like this. Okay? Remember, you cannot cross a vertical asymptote. Now, this part takes care of this. So now let's look to the end behavior. This is telling you that g of x is going to minus infinity, which means has to go down as x goes to infinity. And also says that g of x goes to infinity as x goes to minus infinity. So there is more than one possibility to this, but as x goes to infinity, remember this has to go to minus infinity. So it's very likely that the graph will do this, And on the other side, the graph will do this. Okay? So that's one possibility. You have more than one. Okay, so now let's look to the horizontal asymptote. The phrase says the following: the line y equals to b is a horizontal asymptote of the function y if what? If f of x approaches b as x goes to infinity or x goes to minus infinity. Okay, so that's what it means to be a horizontal asymptote. Okay, so let's do this graph. Says draw a graph h of x that has a horizontal asymptote of -3. So -3 is here. This is y equals to -3. Now, unlike vertical asymptotes, horizontal asymptotes, you can cross them and nothing happens. Okay. Then you need to have the following zeros. It has a 0 of x equals to 1, which is here with multiplicity 1, and -1 with also multiplicity 1. Okay? So this part satisfies this, and the end behavior is that as x goes to infinity, this approaches to -3. So the graph could do the following. Okay, this is one possibility. It's approaching to 3. And as x goes to minus infinity, this approaches -3. That's one possibility. You could also have something like looks like this. And this. The graph could also do this in here as long as it settles to y equals to -3. Okay? We have multiple versions. So just to recap, a vertical asymptote you cannot cross, so these two lines cannot be connected, but a horizontal asymptote it is okay to cross. All right, let's look to the following graph. The first question is asking you is something that I asked you multiple times before to find the domain. Remember, for the domain you cannot divide by 0. That means x cannot be 2, which is the case here, and x cannot be -2, and those will be the vertical asymptote. So you have a graph, it's pretty easy to see which one it is. So therefore the domain will be from -infinity to -2, or -2 to 2, or 2 to infinity, or you can just say x cannot be 2 and x cannot be -2. That's the domain. Now for the horizontal asymptote, would be the end behavior as x goes to infinity or minus infinity. Now, this graph actually is not complete, so if this keeps going, this approaches 3, and in this side also approaches 3. So you have something on the test, it should be clear. So here the horizontal asymptote is y equals to 3. Okay? So that means that x is approaching 3 as x goes to infinity, and f of x is also approaching 3 as x goes to minus infinity. That's what it means to be the end behavior. Remember that this is the same thing as the horizontal asymptote. Now the coordinates of the y-intercept, the y-intercept is right here, so that will be 0, 3. Now the function obviously has vertical asymptotes at x equals to -2 and x equals to 2. Now from the graph, it's obvious that as you are approaching to -2 from the left side, this is going to minus infinity, and -2 from the right side, this is going to positive infinity, okay? So f of x goes to infinity as x approaches to -2 from the right side, and going to minus infinity as you approach to -2 from the left side, which is this. And then f of x is going to infinity as you approach to 2 from the right side, which is this one, and minus infinity as you approach to 2 from the left side. Now the function has x-intercepts here and here. Those are the only two x-intercepts. So they happen at the point negative 4, 0 and 1, 0. And each of these zeros has multiplicity 1. All right, question 6 is asking to do a line to check where this is positive, okay? So you don't really need the line. All you have to do for this case is look to the graph. And if you look to the graph, in green, I'm going to highlight the part that is positive. So clearly this part is positive, this is positive, and everything else here will be positive. So therefore, if you write an interval notation, this will be positive from minus infinity to negative 4, including the 4, because it has equals to 0, or from minus 2 to 1, or 2 to infinity. Notice that the minus 2 and the 2, they have to have a parenthesis since they're not part of the domain. And also notice that in this question, pretty much it has asked you to do 80% of the stuff you learned so far related to polynomials and rational expressions. So it's asking you everything from domain, asymptotes, and behavior, multiplicity, zeros, where it's positive, and so forth. All right, you didn't get the last example. This is the chance to redeem your sins. Let's try one more time. First question, what is the domain? You look to the graph, you cannot divide by 0, so therefore x cannot be 2 and x cannot be negative 2, which again, this is going to be also the vertical asymptotes. Now, most likely you need to write the answer in interval notation, which will be minus infinity to minus 2, minus 2 to 2, or 2 to infinity. Okay? Again, the graph is not complete, and in a little bit I'll show you anyways how to find the vertical asymptote even if you didn't have the graph. But if this keeps going, this actually again approaches 3, and this one would also approach 3, which you can kind of see that this is 1, 2, we will get to 3, and this will also get to 3. So therefore the horizontal asymptote again is y equals to 3, which means that f of x approaches 3 as x goes to infinity, and 3 as x goes to minus infinity. Now the coordinates of the y-intercept, in this case it will be 0, 1, which is right here. And then the function has a vertical asymptote again at x equals to 2 and x equals to negative 2, which is here. Okay. Now the end behavior near the asymptote, well, you can see that as you're approaching 2 from the right side, this is going to infinity. So this goes to infinity as x approaches to 2 from the right side, and f of x goes to minus infinity as x approaches 2 from the left side. Now if you look to minus 2, minus 2 is approaching to minus infinity. You're coming from the right side, so to minus 2, and then 2 from the left side as you come to minus 2, which is here. From the left side, this goes to infinity. So that's the end behavior. Now the function has an x-intercept at negative 1, so it's negative 1, 0. and the multiplicative is 2 or even. Should be even multiplicative. And then the last part is asking you where this is negative. And negative, remember, just means is below the y-axis. So I'm going to highlight on yellow the part that is negative. So clearly this is negative all of this. So it's going to go from minus 2 to 2, not including the, actually it's minus 2 to minus 1, or minus 1 to 2, because at minus 1 is equals to 0, and there is no equal sign there. Now in the next examples, they don't give you the graph, they just give you the equation. And you can use the equation. It's a little harder when you don't have the graph, because if you have the graph, you can clearly see the intersects, you can see where it is increasing, decreasing, and all that stuff. But you can still solve these problems without the graph, and that's what we want to do in the next examples. All right, so let's say you have this rational function, and it's asking you to find the horizontal asymptotes. First, I'm going to show you the long and technical way, and then the easy way to do these things, and you decide which way you want to do it later. So the bottom, this is actually the same thing as x squared minus 2x plus 1, and you'll see why we have to do that in a little bit. This is not asking you for the domain, but if it asks you for the domain, clearly you can see that x cannot be equals, that x cannot equals to 1. So that implies that the vertical asymptote is x equals to 1, even though that's not asking you for that. It's asking you for the horizontal asymptotes. Now for the horizontal asymptotes to work, you just need to remember one thing, which we did at the very beginning, but just recall this. This is going to be very important. Recall that if you have any constant divided by x to any power, that this goes to 0 as either x goes to infinity or x goes to minus infinity. So that's the key to what we're going to do right now. Okay. So what you're going to do, and this type of factoring is going to be very, very, very useful in calculus. This is what we're going to do. So you're going to factor the biggest exponent, which in this case is x squared on the top. So this will be x squared times 2 minus 4 over x plus 5 over x squared. Again, if you multiply this times that, you get this times that, you get that, this times that, you will get that. Then do exactly the same thing on the bottom. So this will be x squared times 1 minus 2 over x, and then plus 1 over x squared. Okay, exactly same thing. And then you can see that this will cancel out. And then what happens to this as x goes to infinity? Well, based with this rule, this will go to 0, this will go to 0, this will go to 0, and this will go to 0. So as x goes to infinity, that implies that r of x is going to go to 2 over 1, which is 2. And this will be the horizontal asymptote. The same thing is going to happen as x goes to minus infinity. R of x is going to be 2 over 1, which is 2. And again, that's a horizontal asymptote. Right now, here is the easy way to do this. Okay. And this is a very useful skill to have, not just now, but when you take calculus. If you have a rational expression, remember the type has to be a polynomial. And remember, a polynomial has a leading coefficient and degree. Okay, so let's say you have this, and on the bottom you have this. Okay, so if the degrees are the same, then the horizontal asymptote is just going to be y equals to a over b. You just divide the coefficients, which You can see here this is 2, this is 1. 2 over 1 is 2, which is exactly what we got. Now, if n is less than m, which means the one on the bottom is bigger, this is actually the easiest one of all, then the horizontal asymptote is going to be always equals to 0. The issue is going to be when the top is bigger than the bottom, then you're going to get a slant asymptote, and you have to do a little more work, okay? But if the degrees are the same, you just divide the coefficients. For example, for this one, for the next example, example 4, you can see that the highest degree is 2, so they have the same degree, so it will be the first case. So therefore, the horizontal asymptote is going to be just y equals to 3 over 2. And that's it. Now, if you just change one exponent, so let's say the r of x was equals to 3x squared minus 2x minus 1, but the bottom was now 2x cubed plus 3x minus 2, so this is the only change right here, the exponent. So now the one on the bottom is bigger, so that implies the horizontal asymptote is going to be y equals to 0. And yes, it is that easy, okay? Now, if you're going to take calculus, I recommend you to do the long way at least one more time, because you're going to need that in calculus. So remember, you factor the biggest exponent on the top, which is x squared. So here you have r of x equals to x squared times 3. This is 2 over x minus 1 over x squared. And on the bottom, this will be x squared again. This is 2 plus 3 over x minus 2 over x squared. And like I told you, this cancels, so that means r of x is approaching at 3 over 2. This will be 0, 0, which is just 3 over 2. Okay. So you can just do this for the exam. That's perfectly fine. But you're going to take calculus, you're going to need to know this, because the problems get more tricky, and then this will not work. Okay? So make sure you give it a try to the long way. All right, so let's look to the next example. Here you can see that the degree of the top is 1, the degree of the bottom is 2, so the bottom is bigger. So therefore, that automatically implies that the horizontal asymptote will be y equals to 0. That's it. Okay? Now, if you factor the bottom, this is x plus 5 squared. So that means the domain is x cannot be negative 5. So the vertical asymptote will be x equals to 5. Now the question is also asking about the end behavior. Remember, the end behavior is related to this. So that means that y goes to 0, or in this case, r of x goes to 0 as x goes to infinity, and r of x also goes to 0 as x goes to minus infinity. Okay, remember that this is exactly the same thing as this. Now, the only thing that we haven't determined here, but the question is not asking you, so we already know that x equals to negative 5, you have a vertical asymptote. So here you have several choices. The graph could do this or this. We could do this and then this, which is actually what happens. It could look like this. But the question is not asking you that. It's just asking for the vertical asymptote. So here it is. Horizontal asymptote. Now, I already told you about this. This is technically the easy way to do it, but let's just formalize it again. If n is equals to m, that means you're going to have an x to the n plus plus, and on the bottom is going to be bn x to the n plus plus. So the horizontal asymptote is just going to be AM over BN, whatever it is. Now, if M is less than N, then R has a horizontal asymptote of 0. We talked about that already. And the only one we haven't done yet is when the top is bigger. So this is called a slant asymptote. Okay. All right, let's look to example 4 again. We did this one already. Now we're just gonna find a few extra things. So it's asking you to find the x and y intercepts. The easiest one is the y-intercept, so let's do that one first. So remember, y-intercept means x equals to 0. If we plug in 0 in here, this will be 0, 0, 0, 0, so the only thing left will be 1/2. So that means that the y-intercept is the point 0 and 1/2. Now for the rest, we're going to need to factor this. So the factor of the top is going to be 3x plus 1 times x minus 1. And the bottom is going to be 2x minus 1 times x plus 2. And you should check this factoring. So therefore, to find the x-intercepts, you only look to for the x-intercepts, you only look to the top, and you want to make the top equals to 0. So that means that x has to be negative 1/3, which gives you the point negative 1/3, 0. Or x will be 1, which gives you the point 1, 0. You also want the vertical asymptotes. And remember, the vertical asymptotes is whatever is not part of the domain. So the domain will be everything except for x equals to 1/2 for this one, and x equals to negative 2 for this one. So the vertical asymptotes will be minus 2. You need to have a hole there because you cannot cross that line, remember? And also a 1/2, which will be somewhere here. So these are the vertical asymptotes. The x-intercepts are negative 1/3, which will be this one, and 1, which will be this. Now, we already found that the horizontal asymptote for this one was y equals to 3 over 2. Remember, since they have the same degree. And that's going to be the end behavior. That means that this goes to 3/2 as x goes to infinity, 3/2 as x goes to minus infinity. So therefore, it doesn't matter what the graph does. The graph eventually has to go to this value, and eventually has to go to this value, to the 3/2. Okay. Now here you have two asymptotes, x vertical asymptotes, x equals to 1/2, which is this one, and x equals to minus 2. So remember that this line and this one cannot be crossed. Now to find out what happens close to this, since you don't have the graph, well, you can just use a graphing calculator, or you have to plug in values close to that. For example, you're approaching from the right side. Let's say you pick 3/4 or 0.75. If you put that in here, notice how this will be positive. 3/4 will give you negative. Actually, let me do that. So the first one will be positive. This one will be negative. This one will be positive, and this will be positive. So the whole thing will be negative, which means that the graph is going to go down in here. Now do the same thing with here. Let's say 1/4. If you do 1/4, then the first one, this will be positive, clearly. This one will be negative. This one will also be negative. And the other one will be positive. So the whole thing will be positive. So that means that the graph on this side will go this way. actually it will go this way because it has to cross to this point, and here it has to cross to this point. So for this particular point, for 1/2, so as x approaches 1/2 from the right side, this will go to minus infinity, and this will go to positive infinity as we approach 1/2 from the left side. So if we do a better graph in here, so if we put this information in here, this is what we have so far. This is going to minus infinity as x is getting closer and closer to 1/2 from the right side. We already know that the horizontal asymptote is 3/2, so it will do this. On this side, we already said it's going to infinity, so it will look like this. And you should check that the graph here will do this. And then finally, if you check some points in here and in here, you will see that when this is getting close to minus 2 from the right side, it's going to minus infinity, and minus 2 from the left side is going to positive infinity, so it will do this. So that's how the graph is going to look. Finally, we did this example, so let's do again. So this is asking you first to do the graph. So let's start with finding the horizontal asymptotes, which we did already. Remember, the horizontal asymptote was that y equals to 0. So that means y goes to 0, this goes to infinity, or minus infinity. Then you need to find where this is decreasing and where this is, what is negative and equals to 0, and what is negative. So we need to factor the bottom, so this is x plus 5 squared. So that means you have a asymptote, vertical asymptote here. So x equals to -5, this will be the vertical asymptote. We also need the x-intercepts and the y-intercept. So the x-intercept will be when 5x minus 20 is equals to 0. That implies x equals to 4, so this will be the point 4, 0. So this will be the x-intercept. And then the y-intercepts, or the y-intercept, there's only one y-intercept. Remember that y-intercept is when x equals to 0, so if x is 0, this will be minus 20 over 25, which is minus 0.8. So the y-intercept will be minus 0 minus 0.8. Okay. All right. So we need to figure out where this is decreasing and where this is increasing, even though the question is just asking you whether this is actually negative. So let's check a value here and a value here. If we plug in -4 on the top, well, clearly that will be negative. And notice that the bottom is always positive, because even if this was negative, you square, it becomes positive. And negative or positive is negative, which means that the graph has to be going to negative infinity on this side. If we do -6, we're going to get exactly the same thing. Negative or positive will give you negative, which means that the graph is doing this. And then we know that this point is equals to 0. So it's very likely that the graph is going to look like this. It's going down. And at this point, it will be 0. Okay, here. So you need to know if the graph is going to go that way or going to go this way. Now, if you check 5, so let's say we check point 5, you can see that the top is going to be positive, and the bottom will also be positive. So this is positive. So the graph will go like this. Notice that the horizontal asymptote is y equals to 0, which means that the graph has to settle to 0 on this side and 0 on the other side. We already know that this part is always negative, and that this is negative up to this point, and then it will be positive for all the values after that. So the question is asking where is this negative. Well, this will be negative equals to 0 from minus infinity until you get to negative 5, or negative 5 once you get to 4, because at 4 this is exactly equals to 0. Now if you want to just strictly negative, then the 4 will have a parenthesis. Therefore the graph, like already mentioned, should look like this. At this point you have the vertical asymptote. This is the x-intercept. The y-intercept is minus 0.8, which is somewhere there. So the graph actually looks like this. It has to 0 to 0. And in this side, it looks like this. It has to 0 to 0. So this is the graph. Now, the question is not asking you about that right now, but you can see that f of x goes to minus infinity as x approaches to minus 5 from the right side, and f of x goes to also minus infinity as x approaches to 5 from the left side. And that's it, people.